One of the greatest scientific missions of modern times has taken a giant leap forward today with the launch at lunchtime of the James Webb Space Telescope.
What if everything we thought we knew about the universe is wrong? The James Webb Telescope just found galaxies that are too big, too old, and too evolved to exist. It's detecting signals from beyond the edge of space. A strange pulse, like a heartbeat, echoes through the cosmos. And a beam of light just bounced back from something. This isn't just science, it's a warning. Reality might be breaking, and we may not be alone. Join us. How we thought the universe worked. For over a century, we thought we had the universe more or less figured out. From the Big Bang to the birth of stars, galaxies, and planets, everything seemed to follow a sequence. A timeline rooted in logic, tested by observation, and supported by math. But what if that timeline is wrong? What if the laws of physics, the same ones we use to describe everything from falling apples to orbiting planets, have just failed us at a cosmic scale? And what if the most powerful telescope ever built has not just seen deeper into the universe, but seen something it wasn't supposed to? Something that breaks the rules. What exactly did we get wrong about the universe's past? And why are scientists suddenly rethinking everything they once believed? According to the standard model of cosmology, the universe began approximately 13.8 billion years ago in a single rapid expansion event known as the Big Bang. This wasn't an explosion in space, but rather the expansion of space itself, a point of near infinite density suddenly stretching outward. Almost immediately, the universe was filled with a hot, dense plasma of particles and radiation. As things cooled, atoms formed, and around 380,000 years after the Big Bang, light was finally able to travel freely through space. That leftover radiation is what we now detect as the cosmic microwave background, a faint glow that permeates the entire universe and acts like a baby picture of everything that exists. From this starting point, the universe expanded, cooled, and matter began clumping together under gravity. Over hundreds of millions of years, the first stars were born, and later, small proto-galaxies began to form. These early structures slowly merged and grew into the vast galaxies we see today. According to this model, it would have taken hundreds of millions, even billions of years for galaxies to reach the size and complexity we observe in our local universe. That's what our models have told us for decades, that cosmic structure emerges gradually over time. The Hubble Space Telescope, launched in 1990, helped confirm much of this narrative. It showed us galaxies in various stages of development, helped us calculate the rate of the universe's expansion using something called redshift, where light from distant objects stretches as space itself stretches, and provided some of the first precise measurements of what's called the Hubble constant, the speed at which galaxies are receding from us. Redshift also allowed astronomers to determine how far away, and therefore how far back in time, a galaxy or star is. And based on this, we set limits on the observable universe, the portion of space from which light has had time to reach us since the beginning of time. To explain some lingering mysteries, like why galaxies don't fly apart or why the universe's expansion is accelerating, scientists introduced two key ideas: dark matter and dark energy. Dark matter is thought to make up most of the universe's mass, even though it doesn't emit or absorb light. It's the invisible glue holding galaxies together. Dark energy, on the other hand, is believed to be the force behind the accelerating expansion of the universe, like an invisible pressure pushing everything apart. Neither has ever been directly observed, but both fit the equations and solve the problems, for now. All of these components are part of what's called the lambda cold dark matter model, the standard framework for understanding the cosmos. It combines Einstein's general relativity, quantum field theory, and astronomical observations into one coherent picture. And until recently, this model fit almost everything we saw, from galaxy rotation curves to the distribution of matter on cosmic scales. But there's a catch. It only works if the assumptions we made about the early universe are correct. And that's where things are starting to unravel. Enter the James Webb Space Telescope, or JWST. Launched in December 2021 and fully operational by mid-2022, Webb was designed not to replace Hubble, but to look even further back in time, deeper into the cosmic past than ever before. Instead of using visible light like Hubble Webb sees in the infrared spectrum. Why does that matter? Because light from the earliest galaxies has been so stretched out over billions of years of expansion that it's now only detectable in infrared. That means Webb can pick up the faintest, oldest signals from the most distant corners of the universe, potentially from just a few 100 million years after the Big Bang. Now, Webb found fully formed, massive galaxies where there shouldn't be any. And if they exist, then something is seriously wrong with our understanding of the universe. Impossible galaxies and the discovery that changed everything. Just months ago, scientists using the James Webb Space Telescope uncovered something so alarming that it's being described as a crisis for modern cosmology. It's not a distant theory or an abstract idea. It's actual data, fresh from the edge of space and time, showing us galaxies that simply should not exist. These galaxies are not just faint smudges or borderline detections. They are massive, bright, and fully formed, sitting where no galaxy that advanced has any right to be. The most shocking part? They existed just 280 to 300 million years after the Big Bang. Barely the blink of an eye in cosmic terms. So the question now is painfully simple. How did entire galaxies, containing hundreds of millions of stars, emerge when there was supposedly no time, no ingredients, and no physical possibility for them to exist? The James Webb Telescope, with its unmatched sensitivity to infrared light, detected several of these impossible galaxies almost immediately after it began full operations. Among them are now famous names like JADES GSZ14-0 and MOM Z14. These aren't just interesting finds, they are rewriting our understanding of the early universe. JADES GSZ14-0 is currently one of the most distant galaxies ever observed, with a redshift of approximately 14.18. That places it just around 280 million years after the Big Bang. Meanwhile, MOM Z14, at a redshift of about 14.44, holds the current record for the earliest confirmed galaxy in cosmic history. But it's not just how early they appear. It's what they are that is shaking scientists to their core. Under the standard cosmological model, galaxies form slowly. First, gas collects in halos of dark matter, cooling over time, eventually condensing into stars. Those stars form clusters, and over hundreds of millions of years, enough stars gather to form a faint, primitive galaxy. These first galaxies are expected to be small, dim, and chaotic, barely visible even to a telescope as powerful as Webb. But JADES GSZ14-0 and MOM Z14 are the exact opposite. They are too big, each one containing hundreds of millions of solar masses worth of stars, possibly more. They are too bright, emitting strong ultraviolet and infrared light, indicating intense star formation activity. And most disturbingly, they are too chemically evolved, meaning they already contain elements like carbon, oxygen, and nitrogen, which should only appear after multiple generations of stars have lived and died. This creates a paradox. At that point in the universe's history, there simply shouldn't have been enough time for even a single full star life cycle to complete, let alone several. The presence of these heavier elements, what astronomers call metals, suggests that stars had already been born, gone supernova, and seeded their surroundings with enriched material. That process alone should take hundreds of millions of years. And yet, here we are, observing galaxies where this has already happened, only 200 to 300 million years after the supposed beginning of time. Why is this impossible? Because based on everything we thought we knew, the early universe was still in its chaotic infancy at that time. It was hot, dense, and mostly filled with neutral hydrogen. Star formation should have been inefficient and slow, with small galaxies gradually assembling over long stretches of time. These new galaxies defy that picture entirely. They are structured, luminous, and enriched, and they exist too early, in too much abundance, to fit within any current model of how galaxies form. And they are not rare anomalies. Webb has now identified dozens of similar galaxies at similarly extreme redshifts. We're not talking about one or two flukes. We're talking about a population, a whole class of ancient, oversized galaxies that appear again and again in different fields of view. If just one of them existed, it might be explainable as a statistical outlier or a misreading of the data. But with this many, across this wide a region of space, that explanation collapses. The problem is no longer with the observations. It's with the theory. Under standard galaxy formation models, a typical galaxy converts about 10% of its gas into stars over time. This is a well-studied and relatively consistent pattern observed in thousands of nearby galaxies. But JWST has found early galaxies that seem to have converted almost 100% of their gas into stars, leaving no dust, no gas clouds, just raw starlight. That's like watching a city build itself instantly with no scaffolding, no materials left over, and no record of construction. It doesn't just raise questions, it shatters assumptions. Some scientists are now voicing a stark choice. Either we are wrong about how galaxies form, or we are wrong about when they form. One researcher put it bluntly, either our models of early galaxy formation are catastrophically incomplete, or our understanding of the timeline of the universe is fundamentally flawed. This isn't just a debate about tweaking a few numbers in an equation. It's about whether the entire sequence of cosmic history, starting from the Big Bang and progressing through time, is based on a misunderstanding of what really happened. How could this be possible? One hypothesis is that star formation in the early universe was far more efficient than previously believed, perhaps driven by unknown physical mechanisms or environmental factors that no longer exist today. Another possibility is that these galaxies formed not from gradual processes, but from massive direct collapse events. Giant clouds of gas rapidly turning into stars without the slower fragmentation process we observe in local galaxies. But even those speculative models struggle to explain the metallicity and structure of the galaxy's web has observed. The math still doesn't add up. There's also the idea that something about our measurement of time might be off. Maybe what we interpret as redshift, a stretching of light due to cosmic expansion, is influenced by factors we haven't accounted for. Could the early universe have expanded in a non-linear way? Could the constants we take for granted, like the speed of light or the gravitational constant, have behaved differently under extreme early conditions?